In this question from the chapter Similar Triangle, it says, prove that the line segments joining the midpoints of the sides of a triangle form four triangles, and each of which is similar to the original triangle. So let's begin with making a triangle first. I made a triangle over here, and I'm going to join the midpoints of these sides. Let's say if I take these as the midpoints of these sides, and joining these midpoints, we obtain a triangle. And what we need to prove that this triangle so formed over here is similar to the original triangle, right? So let's say if I mark the triangle name as ABC, and let's say P being the midpoint of AB, Q being the midpoint of AC, and R being the midpoint of PR. Now, what we need to prove in this question is to prove that this triangle, uh, there are four triangles, right? So let's say this triangle is similar to the original triangle, that is ABC. And we also need to prove this triangle, say APQ is similar to this. And finally, we'll also be proving this triangle similar to this whole triangle and this to be. So let's begin with proving the central one, right? Proving the central one. So now we are going to use the midpoint theorem over here, the midpoint theorem that you have studied in class 9th. So what we know that here, line joining the midpoints of two sides of a triangle. I repeat, the line joining the midpoints of two sides of a triangle is parallel to the third side, and it is half the third side. So this way we can say that, this way I can say that by midpoint only, we can say that PQ is parallel to BC, and we have PQ as half of BC. Well, if PQ is parallel to BC, it also implies that it is parallel to BR as well. BR. And similarly, I can write PQ, which is half of BC is what? BR again. So what you can see that when you prove same pair of opposite sides of a quadrilateral equal and parallel, it becomes a parallelogram. So you can say that therefore PQRB is a parallelogram. Now, if this figure is a parallelogram, if this figure is a parallelogram, then what we can say that their opposite angles are equal. So I can write over here that this angle, say 1, is equal to angle B, and this angle, say 2, is equal to angle C. So I can write, therefore, the triangles, we have to mention the name of the triangle. So that is triangle PQR and the triangle ABC. So we have angle 1 is equal to angle B, and angle 2 is equal to angle C. Therefore, we'll write the triangle that is, say, PQR is similar to, what is P corresponds to C, right? So CQ corresponds to BA. So we proved one, but we have more to do. Now for proving the other triangles similar, what I'm going to use is number 1. Can we say this angle is equal to this angle as the lines are parallel? So we can say that their corresponding angles should be equal. Right. So let's say consider the triangle over here. The triangle taken over here is the in triangle APQ and ABQ. This is and. So over here, this angle, say angle 3, should be equal to angle 1, being corresponding angle. Angle 3 is equal to angle B, and angle B is common. No, angle A is common, right? Angle A is common. So angle A is equal to angle A common. So this is by, above one is by corresponding angles, and this by common. So we can say now the triangle APQ similar to triangle ABQ. Right. And then we have one more triangle like this. So we can use similarly, but let's prove one more. So using corresponding angle property also, one angle is C. And now check here. I can mark this angle, right? This angle should be equal to this angle. So if I mark this as angle 4, this should I mark as 4. So now I must mention the name of the triangle. Here we are proving triangle PBR, and right, the other triangle which I'm taking here is, no, PVR is done, right? No, not PBR. We are taking QCR, and Q corresponds to A, R corresponds to B and C. So over here you can see angle C is equal to angle C common, and angle 4 is equal to angle B. This angle 4 is equal to angle B. That's by corresponding angle. So therefore here these two triangles also become similar. That is, triangle QCR is similar to triangle ABC. Now for the rest part you can write similarly. We are left with this triangle, right? This triangle is also similar to the other. So that's why we will prove this question.